Can you solve this geometry challenge? Here's the question. Given this right triangle ABC, draw a circle inside of this triangle with center O. Now, the length of segment AC equals 12 units and the length of segment AB equals 13 units. Now, the question is, what is the distance of this center O to this vertex B? Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so, given this right triangle, our goal is to find the distance of this center O to this vertex B, or the length of this segment OB. Now, let's draw the segment that we want to find. So, here it is. We have segment OB. Now, to find this segment OB, what we're going to do is first, look for the radius of this circle O. Now, take note, the radius of this circle O must be perpendicular to this side CB because CB is tangent to this circle O. Alright. Now, once we found the measure of this radius, then we are almost done. Alright. Now, let's do that. And to answer this, what we're going to do is to use the Pythagorean theorem. Now, why we use Pythagorean theorem? Because we want to find the length of this segment or this side CB. Now, using Pythagorean theorem, we can say that AC squared plus BC squared equals AB squared. Now, this AC must be given, which is equal to 12 units. And this AB is also given, which is 13 units. Now, let's simplify. And let's solve for the value of CB or BC. Now, 12 squared must be equal to 144. 13 squared must be equal to 169. Now, let's subtract 144 on both sides to get the value of side CB. 169 minus 144, this will give us 25. And then, let's get the square root on both sides. Now, since it is a side length, we need to focus on the positive value of BC. Alright, now on the left hand side of our equation, we have CB, and on the right hand side, we have square root of 25. And we know square root of 25 must be equal to 5. Therefore, the length of this side CB or BC must be equal to 5 units. Now, we know this segment right over here must be the radius of the circle O. So, let's call this as R. Now, at this point, let's get the measure of this radius, R. And to do that, we know that the length of the radius of a circle inside of a right triangle must be given by this formula, A plus B minus C all over 2, wherein A and B are the legs of the right triangle, and this C must be the hypotenuse or the longer side. Now, the legs of this right triangle must be given. We have 5 and 12. And we have the hypotenuse or the C must be equal to 13. Now, let's substitute all this given. So, we have 5 plus 12 minus 13 over 2. That is the length of the in radius of this circle. Now, 5 plus 12, this is equivalent to 17. And 17 minus 13, this is just 4. And 4 divide this by 2, we get a value of 2. So, we can say that the length of the radius of the circle inside of this right triangle must be equal to 2 units. Now, we are almost done. So, let's draw another radius of this circle. And we know this is perpendicular to side AC because, again, side AC is tangent to the circle O. Now, notice that we create a small square right over here. And the length of the side must be the length of the radius of circle O, which is equal to 2. So we can say that the length of this side from this point to this point must be equal to 2 units. Now take note that the length of the side CB must be equal to 5 units. Therefore, we have 2, so the other segment must be equal to 3. Now, we are now ready to find the measure or the distance of this center O to this vertex B. Now let's focus on this right triangle. And since it is a right triangle, we will use, of course, the Pythagorean theorem. So we have OB raised to the power of 2 must be equal to 2 squared plus 3 squared. Now let's simplify. 2 squared, this will give us 4. And this 3 squared, this will give us 9. And finally, 4 plus 9, this will give us 13. And to solve for the value of segment OB, let's get the square root on both sides. And again, since it is a side length, we are interested to the positive value of this segment OB. So, the left-hand side of our equation must be equal to OB, and the right-hand side must be equal to positive square root of 13. And that is our answer to this question. Therefore, given this figure, we can say that the distance of this center O to vertex B must be equal to square root of 13 units. And as always, we are done.